Hi guys, today I'm gonna show you a nice question in classical mechanics which is about the friction-free motion of a block on a moving ramp and finding the contact force. Let's get started. A ramp of mass m1 lies on a horizontal table and a block of mass m2 slides down the ramp. Denoting the normal force between the masses by n, calculate n in terms of m1, m2, the inclination angle alpha, and the gravity field g. Assume that all contact surfaces are frictionless and the system starts at stationary. Pause the video and see if you can come up with a solution. Alright, this quick demo shows the motion of system over a short period of time. You can see that as the box slides to right, the ramp slides to left. The displacement amount for each depends on their masses. In this demo, the box slides to a greater amount because it is lighter, but the ramp slides less because it is heavier. The first step in solving this problem is sketching the free body diagram. FBD. A free body diagram shows all the forces that are present in our problem. The normal force like this, and this is the gravity. We want to find this angle here. To find this unknown angle, we use this figure. Here is alpha, and we want to continue the straight lines here. This is the right angle here. This must be a right angle too. And we look at the triangles A, B, C, and A, D, C. The triangle A, B, C is similar to A, D, C. Why? Because they have a common angle C and they are both right triangles. So this angle here, which I denote by X, is equal to alpha. On the other hand, the lines D1 and D2 cross each other, and this angle here should be equal to X, which is now equal to alpha. So this is exactly the angle that we were looking for. So this angle here is alpha. From the FBD, the horizontal force supplies the motion in X direction. The horizontal force is Nx equals N sine alpha, which is M2 X double dot 2. And X double dot means the second derivative of X with respect to time. And by Newton's third law, this must be exactly equal to minus m1 x double dot 1, which is just the horizontal acceleration of mass 1. The vertical force from the FBD is ny minus mg, which is equal to m2 y double dot 2. And we additionally have ny equals n cosine alpha. To find a normal force, we need an additional constraint equation which comes from geometry. So M1 observes M2 accelerating downward and to the right at an angle alpha. AR, which is the relative acceleration. We have tangent alpha is equal to minus ARY over ARX. ARX, ARY. The minus sign is because ARY is downward and we want tangent alpha be positive. Minus y double dot 2 minus y double dot 1 over x double dot 2 minus x double dot 1. Y double dot 1 equals A1 y, which is 0 because the vertical displacement of M1 is 0. Tangent alpha minus y double dot 2 divided by x double dot 2 minus x double dot 1. We name these relationships by 1, 2, and 3. From 1 and 3, tangent alpha equals minus y double dot 2 x double dot 2 minus m2 over m1 x double dot 2, which is minus y double dot 2 over x double dot 2 times 1 plus m2 over m1. Now from 2 we have y double dot 2 equals n cosine alpha minus m2g, this should be m2, divided by m2, which simplifies to n cosine alpha over m2 minus g. Moreover, from 1 we have x double dot 2 equals n sine alpha over m2. Let's box these two relationships for x double dot 2 and y double dot 2 and plug them into this relationship for tangent alpha. So we plug them in here. and we have tangent alpha equals g minus n cosine alpha over m2 divided by n sine alpha over m2 times 1 plus m2 over m1. And we multiply the numerator and the denominator by m2 to get m2g minus n cosine alpha divided by n sine alpha times 1 plus m2 over m1. We get m2g minus n cosine alpha equals n tangent alpha times sine alpha times 1 plus m2 over m1. Thus, n equals m2g divided by cosine alpha plus tangent alpha times sine alpha times 1 plus m2 over m1. And we can simplify even more by multiplying the numerator and the denominator by cosine alpha, and we will see why. Cosine squared plus tangent is sine over cosine, and if we multiply by cosine, it becomes sine squared times 1 plus m2 over m1. Now, in the denominator, we have cosine squared plus sine squared plus sine squared times m2 over m1, which is cosine squared plus sine squared is 1, and the rest, sine squared times m2 over m1. Finally, we get n equals m2g cosine alpha divided by 1 plus sine squared alpha times m2 over m1. To get more intuition of this formula, we discussed the case where m1 goes to infinity, which means that the ramp is essentially stationary. It doesn't move whatsoever. In this case, we have n is just equal to m2g cosine alpha, because this term sine squared times m2 over m1 vanishes and the denominator becomes 1. So n will become m2g cosine alpha.